A uniform dot is placed with its center of mass on a support. A cylindrical bucket is hung at a distance d1 to the left of the rod's center, and a liquid of density ρ1 is poured into the bucket up to a height h1. On the right side, another cylindrical bucket is hung at a distance d2 to the right of the rod's center, and a different liquid of density ρ2 is poured into the bucket up to a height h2. The buckets each have radius r and their masses are negligible. If the rod bucket system is in equilibrium, what is the density ρ2 of the fluid in the bucket on the right? This is a multiple concept question based on thought and fluids. Okay. Here, the system is in equilibrium. So when the system is in equilibrium means the net torque is equal to 0, or the torque is equal to counterclockwise torque. What is torque? Torque is equal to R cross F bar. Here the force is nothing but the force of gravity of each bucket. Therefore, the Fg is equal to mg. And mass is not known to us. Therefore, we have to find out the mass using the density and volume. Therefore, we know density is equal to mass per volume, or mass is equal to density times volume. So, Fg is equal to rho Vg, where rho is the density, and then V is the volume, and G is the acceleration due to gravity. And then volume of the cylinder V is equal to pi r square h. Therefore, Fg is equal to rho times pi r square h times G. Okay, this is the equation. Now we have two different buckets, and then we have the different liquids filled in the buckets. So therefore, the densities are different, and then the quantity is also different for H1 and H2. Now let us write the torque equation using these values. So therefore, torque is equal to R cross F bar. Here R is nothing but your D1 and then D2. Okay, so I put that one. And then the Fg value here we have. So F cross R bar, this one, F1 cross R1 bar, F2 cross R2 bar. Okay, so ρ1 pi R square H1 G D1 is equal to ρ2 pi R square H2 G times D2. And G is common, we can eliminate that one. And then next, pi r squared is also common because he is saying that same radius. The buckets each have the same radius. Therefore, the area of cross section also gets eliminated. And then we are left with ρ1 h1 d1 is equal to ρ2 h2 d2. ρ2 is equal to ρ1 h1 d1 divided by h2 d2. This is the answer for this question. And so here in this multiple choice question, B is the answer. This is the college board multiple choice question in the fluids. Okay. Hope this helps. Thank you. Bye-bye.